Okay, so if we had to describe the process of respiration, not cellular respiration, not anything to that effect, but the process of air being placed into your lungs and gas exchange taking place, and then we could also say air exiting your lungs. And you might be saying or asking yourself, well, how or why is that possible? Well, air also has carbon dioxide in it, so you just have the presumption that air is coming in and oxygen's coming in and carbon dioxide is going out, and that's true because there's lots of other, not a large trace of inert gases, but air is a fairly vague term. The highest concentration is oxygen, that is true, but there's, even when we breathe in, there's still could still be some carbon dioxide, unfortunately even some carbon monoxide. It's just not in very high concentrations. And even when we exhale, there's still large amounts of oxygen when we exhale. Okay? Otherwise, cardiopulmonary resuscitation would just not be possible. So, we drew just a slight sketch on what breathing/respiration would look like. So in order to initiate respiration, what has to happen first? Okay, the signal has been sent from your medulla. We already know that. What's happening to initiate respiration? You can even have a visual aid here, because we did that in class as well. So here's our visual aid, okay? It's about right here. Because the lungs are inside of here and so is the heart, but this structure is right here. It's a separation of some sort between two cavities. No, it's not that. What separates these two cavities? As I say, if I just tell you, say, oh, I knew that. So yes, the diaphragm does that. So in order for that to take place then, okay, the diaphragm contracts. Like I said, like I mentioned, we're already going under the presumption that those nerve impulses are constantly being sent down to your diaphragm. The medulla does that. So the diaphragm contracts. Okay. So once it does that, it's pulling down on the lungs. So then what happens to the volume inside the lungs? So if they're doing this, okay, the diaphragm has pulled down, diaphragm pulls down, so then the lungs do this. According to the gas laws, what's happening to the volume? It's getting what? Right. So the volume is increasing. So once the diaphragm contracts and pulls down on the lungs, volume will increase. And the reason that it's so important to say that it increases, it goes up and above, that's not what we wanted. The volume is increasing, so then what's the pressure doing? That's what I meant to say. So then the pressure is going down, resulting in a decrease in pressure. The reason that's important is this pressure is below possibly what set point? Yeah, it's not going to be the same in New Mexico. It's not going to be the same down in Peru. It's not going to be the same down in Mongolia. Okay, all across the world, atmospheric pressure is going to be different. Okay? So when these lungs expand, volume's going up, pressure's going down. So then what does air/oxygen do? Again, we don't suck that in like a vacuum. It just flows in, okay? So when this happens, the pressure is below atmospheric pressure. And air flows in. Oops. Okay. So then, okay, air's gone, whether it's going in through your nostrils, in through your mouth, down past the pharynx, down past the epiglottis, okay, down through the, I said epiglottis, then down through the glottis, down to your larynx, down in through your bottom part of your trachea, then the bronchial trees, the bronchi, bronchioles. The smallest part of the respiratory system is what? Right, so we're not going to name all those structures, okay? Because those are already in different types of questions. So we just want the presumption that air flows in, and therefore, how is that oxygen absorbed and carbon dioxide released? You already touched upon that. Yes, the alveoli, okay? Air flows in, and at the, we'll say, no, within, that would be better, not at the, within the alveoli, okay, what is it that's surrounding, okay? So if this is an alveoli, it's maybe not the most accurate, but what might these fingers represent surrounding all your alveoli? Yep, okay, so therefore, within the alveoli, the capillary bed okay, oxygen in, carbon dioxide out, okay? Capillary bed, we'll say exchanges. That's a good way of looking at that. You can even abbreviate this, exchanges O2. Of course, good chemistry students know that that 2 has to be there. Why? It's a gas, it's diatomic, exchanges oxygen and carbon dioxide, okay? So that has now taken place. Now we have all of this within this thoracic cavity. It's expanded. Now we got to get that out of here. Of course, it doesn't expand that far, but how might we just go in the opposite direction? It has something to do with this and something to do with your rib cage as well. Okay? So if the diaphragm contracts in inspiration, okay, what's just the opposite then? Well, that's the process, but what's the opposite of contraction? Yeah, it can be. It can. Some things can dilate all the way when they're contracting, but think of when, let's see here, when you're doing this, you're flexing these muscles here, so then what's the opposite of flexion? Extension, but rather than that, you're right, rather than that muscle contracting, what's the opposite of going backwards then? Or I didn't say that right. What's the opposite of contracting? And I say this, you can say, oh, that makes perfect sense. Okay? We just sometimes say, when we're really, really nervous, we'll just say, just take a deep breath and do what? Relax. Okay, so therefore, all this has taken place. The diaphragm relaxes. You know, we make it look like this whole drug out process must take about 3 minutes to do. No, it's, of course. And for our track students running, it's late for science. Okay. All right. So the diaphragm relaxes. Okay. That's not the only game in town because it has something to do again with this rib cage. Why do you suppose is there spaces in between there? What might be? We only verbally said it. Okay, the lungs are in there, but there's also muscle tissue in between these. Okay, those are what we call intercostal muscles. Okay, so the diaphragm relaxes and the intercostal muscles contract. So now you have that contraction on your rib cage. Okay? What is the volume doing inside your lungs? It's going down, okay? Resulting in a decrease in volume. Okay? So now, if this volume is going down, which it is, what is the pressure doing? Yeah, the pressure is increasing so much, okay? After this decrease in volume, the pressure increases. What does it have to do with this right here, atmospheric pressure? Yeah, right. So the pressure increases above So when this happens, the diaphragm relaxes, these intercostal muscles contract, the volume is going down so low, the pressure is increasing above atmospheric pressure, and what does that air do in your lungs? Yeah, it just flows out, okay? So then we can just say above atmospheric pressure and air flows out. Okay. That gives you the rest of the day, today, tonight, tomorrow, tomorrow night, and then Wednesday is the one of two. It's a double feature on Wednesday. Isn't that a good way of looking at it? See, you people are young enough to do this now. Not me. It used to be you could go to Madison for this, to Mitchell. Laverne has something to do with this. We're talking about movies. Drive-in movie theaters. What's significant about going to a drive-in movie theater other than you're in your car? You don't just go there for one movie, correct? Typically, it's a double feature. So then your double feature is on Wednesday. And it's a movie, some movies I'd like to see. It's great watching you people excel because when you work hard, good things happen. Just look at some of the seniors that we've had go through here the last 2 years. I mean, a lot of the scholarship awards that they win, and it's not handed to them, it has to be earned. Okay, is there anything else with this?
Can we go over some general questions?
Okay. I don't see any problem with that. Let's see here. There is just, hold that thought. Okay, reasonable question. Some general questions that you might see is Like, for instance, some of the structures that are in the upper respiratory tract as opposed to the lower respiratory tract, like, for instance, typically a lot of what we associate the upper respiratory tract is something that you can see, okay? Even though you can't see the larynx, that's still part of the upper respiratory tract. It's, for the most part, on the inside. Okay. So again, we know that where does gas exchange take place? We've established that in here. Yeah, in the alveoli, okay? If we talk about a structure known as the glottis, I want you to think about that for just a moment. So the question was, think about, as far as openings are concerned, what might the epiglottis cover? Exactly. So that will prevent materials like liquids and foods from going down into your trachea. It's just a muscular flap. Kind of think about like this here. So when you swallow, it goes down, comes back up, goes down, comes back up, goes down, and it's just a little flap like that. Okay? So then if that's what the epiglottis is, which it is, what's the glottis then? That's also an opening, but it's below the epiglottis. That would be in a different structure. It's not that. It has something to do with sound. Yeah, because that's an opening. The glottis is actually the opening to your larynx. That's what we associate that with. Okay? So how do we know to breathe? Kind of like, we just told you, gosh, well, no, we just said not that you're nervous or anything. Take a deep breath, and then we just say relax. But do we have to think about breathing? No, we don't. You're shaking your head. No, that's correct. So if we don't have to think about it, is it part of the autonomic nervous system or somatic? That's not part of the exam. I'm just asking to see if you know. Or is it part of the somatic nervous system? Yeah, it's part of the autonomic, which means you don't consciously control that. Okay? So therefore, it's one of those aspects to where there's basically only one part of the brain that we said that you don't have conscious control over. What would that be? Yeah, that's the brainstem, which is also the medulla. I was just going to say you're being too specific, but that still answers the question. Yep. So what monitors the carbon dioxide levels in your blood or in your body? It's one of the very last things we talked about. It's one of those things that you just would not think of. It's something that also provides a protective function within your cranium and spinal cavity. Yeah, CSF, cerebral spinal fluid, that's right. So if it's cold outside, where is the air warmed up at? No, that's too far down. It will get warmed up in your lungs, but typically it's going to warm up before it reaches there. And where would that be? Not your mouth. Where else can you breathe through? Yeah, your nose. That's right. So what is it that lies between your lungs? It's a septum, but it's also an organ. Okay. Probably just a little lower. Okay. So what we mean by that, okay, is you have your right lung here, your left lung there, And you're saying trachea, esophagus, yeah, but that would be a little higher up, so it's about right here. Well, on the inside though. It's what causes there to be 2 lobes on this side and 3 lobes on this side. Okay, a little lower than that. Okay, because when we look at that, you're seeing the bronchial tree, which is true, but the bronchial tree is actually right here. So anatomically speaking, what's just a little bit lower than that? And it sits about right here. This is a tough question. It's right in between the left and right lung. Maybe I'm just not asking it very well. The heart. Oh, okay. Yeah. So then what is it? What's that area called where the heart's located in? It's kind of hard to say. Oh, that's what's the heart's within it's a myocardium. That's the actual muscle tissue of the heart. It's a cavity. Not only do you have the thoracic cavity, but where the heart's located, it starts with an M. Yeah, it is something weird. Med something, because it kind of means the middle. We pronounced it 2 different ways. That's so close when you say that. It's not that far off. Medullary cavity, that's further up in your brain, where your medulla is. Or, no, I'm sorry. Medullary cavity, that's where bone marrow's stored. Yeah. When you say medium, you're not that far off. It's actually within the mediastinum or mediastinum or something to that effect. Like I said, we pronounced it 2 different ways. Okay. So when you're talking about where your bronchial split, just like in a tree, you have the trunk that comes up and then it starts to split here. Yeah, bronchial tree. Bronchial branches, bronchial tree. That's right. So we have the trachea, then that branches off the bronchial tree, then you have the bronchus, left and right bronchus, and then you have a whole bunch of branches like this. Then that eventually goes down even further into your alveoli. But these like structures here past the bronchus it's also bronchioles. Bronchioles, that's right. Okay. So one of the things that we said, if we want to raise our voice like that, okay, now we're awake now, okay, when that amplification of sound is occurring, what structure is it going through? Yeah, it's going through your lungs. I get that, and I understand that. But it's what controls the pitch and sound. What structure is that that's in your neck? Yep, it's the vocal cords, that's true, but that's all has one, it's all known as the same structure that we said if that becomes inflamed, you can't talk. Yeah, your larynx. Yep, or laryngitis, for instance. Okay, so those are some of the basic questions that you might encounter. And then lots of vocabulary terms. Well, not lots. I want to say there's only about 15 of them. That we handed your vocabulary quizzes back last week. Okay. Then, okay. I think that's about it. Is there anything else? So just look over what we talked about in class, look over this, your vocabulary evaluations that were handed back to you, and you'll be just fine. Anything else? Do you really need bonus questions? It's just nice to have, kind of like a little extra money in the bank or something like that. See, that's where you talk to your parents. I should get a bonus, right? I don't know if it works that way. Okay, bonus questions. Okay, so now I have this resumed. Some of this I just like to read through. Okay, before the series finale, because every year there's either a season finale, which is the last episode for that season, or it's a series finale, in other words, the last episode. So this happened last week, before the series finale, because this Thursday is the last episode for this. So before the series finale of Young Sheldon, what happened to George? That's the dad. He's no longer in the show because what? Okay? And then, what is the character name of Sheldon's twin sister in Young Sheldon? Not her real name. What's her character name? And then, what is we could say, the imaginary metal found in Wolverine was an X-Men, okay? In Wolverine's indestructible body. This metal does not exist, okay? That's why it's in a movie. So what's the name of Wolverine's indestructible metal found in his body? Of course, a signature, and that is it. So, final, right away, Wednesday morning at 8:30. We'll catch up to you next time.